Hello, this is homework helps for section 4.2. Homework help for section 4.2. This is our absolute extrema, and number 43 is the first one I'm going to do, and it is asking us to find the absolute max and min for over the interval from 0 to 2. So the first thing that we're going to do is we are going to go ahead and simplify what is inside the square root right here. You don't have to do it. I just think that's a more straightforward way to do it. So right here, I have simplified that. You've got 2 minus x squared, 2 minus x squared. I have that written down wrong, hang tight. The square is on the outside. Okay, that's our original problem right here, has the square on the outside. So we have 2 minus x squared. When I FOIL this, I end up with x squared minus 4x plus 4. Okay, I add that to the 2 and I get x squared minus 4x plus 6. So that is what this simplifies to inside the square root. So I've got, and I haven't done anything with the calculus yet. So I've got 2 plus x, and then I have the square root of x squared minus 4x plus 6. Okay, so now I'm going to I'm going to have to use the product rule. So I'm going to identify g of x as 2 plus x. And I'm going to identify h of x as the square root of x squared minus 4x plus 6. Okay, g prime is just going to be 1. Okay, h, we're going to have to do, or h of x, we're going to have to do u substitution. So for u, I'm going to have x squared minus 4x plus 6. F of u is going to be the square root of u, and we know that is u to the 1/2. Okay, so u prime is going to be 2x minus 4. And then f prime of u is going to be 1 over 2 the square root of u. Okay, so then h prime of x is going to be 2x minus 4 over 2 on the square root of x squared minus 4x plus 6. Now I'm going to go ahead and factor out a 2 right here. So that will give me h prime of x is 2x minus 2. And then I can cancel that with the 2 in my denominator. So then I will have h prime of x is x minus 2 over the square root of x squared minus 4x plus 6. Okay, so all of that just to get to where we can do the product rule. Okay, so now I am able to do y prime, or the derivative of y. So I start with the derivative of my first function, and that's going to be 1 times my second function. And so I'm left with square root of x squared minus 4x plus 6. And then I have my second function, or I'm sorry, I have my first function times the derivative of my second function. And that will be x minus 2 all over the square root of x squared minus 4x plus 6. So this is my first function right here, and this is the derivative of my second function. Okay, so that's the product rule. Now I am going to go ahead and clean up this by getting a common denominator. So all of this is over 1. This is going to be my common denominator. This is my common denominator. So what I have to do is I have to multiply the denominator by x squared minus 4x plus 6, And if I multiply the denominator by that to get my common denominator, I also have to multiply my numerator by that. And when I do, it actually makes my numerator very nice, because this right here multiplied times this is going to get rid of my square root. So then I've got y prime equals x squared minus 4x plus 6 plus, and now I'm going to go ahead and multiply this right here, and I'm going to FOIL it. And when I FOIL this, I end up with x squared minus 4. So that's my numerator, and my common denominator is x squared minus 4x plus 6. Okay, and now I'm going to do some cleanup right here. And when I add my like terms, I end up with y prime equals 2x squared minus 4x plus 2. And then my denominator is x squared minus 4x plus 6 right here. Okay, I'm going to go ahead and factor out a 2 in my numerator, just because that's going to help me find my critical numbers. Plus 1. Okay, and then I have x squared minus 4x plus 6. Okay, so now at this point right here, I have my derivative, and I am going to look and see if I have any critical numbers within this interval right here. And the way that I do that is I set my derivative equal to 0, and I look and see where my derivative is undefined. And then if any of those critical numbers fall in this interval, then I have to evaluate them in my original function. So let's talk about a couple of things down here. Let's start with the numerator. To find the solutions for this function, because it's a rational function, we're going to set this right here equal to 0. So I've got x squared minus 2x plus 1. And that is multiplied by 2, and I've set that equal to 0. Okay? So when you find the solutions of a rational expression, you just set the denominator equal to, or the numerator equal to 0. When I factor this, I end up with x minus 1 squared. And so a number that I have to be aware of as a critical number is x equals 1. Now, when I set the denominator equal to 0, I've got to solve what is inside my square root. And when you look at it, you're not going to find two numbers whose product is 6 and sum is negative 4. So you have to think about, well, I'm going to have to complete the square. I'm going to have to use the quadratic formula. Well, when we use the quadratic formula and we think about whether or not this is imaginary or not, if we think about the discriminant in a quadratic, so b squared minus 4ac, that's our discriminant, and that's going to tell us if I have real solutions or if I have complex solutions. So when I do this, I end up with negative 4 squared minus 4 times a times c. And when I do that, I end up with 16 minus 24, and I end up with negative 12 as our discriminant. So what that means is any solutions to this right here are going to be complex. And because they're complex, they are not going to fall in this interval that we are looking at for this problem. So I don't have to worry about any of the values that I would get from the denominator because they're complex imaginary numbers. So what I've got is I've got a critical number of 1 that I've got to focus on, and then I've got to focus on the endpoints 0 and 2. So at this point, I am going to find f of my endpoint 0 and I'm going to find f of my other endpoint, which is 2, and I'm going to find f of positive 1. Okay, so I take my 0, my 1, and my 2, and I put it back in my original function. So when I'm finding absolute max and absolute mins, I go back to my original function. And when I plug f of 0 in, I get 2 on the square root of 6. When I plug in 1, I get 3 on the square root of 3. Wait, let me check that real quick. 2 minus 1 is 1 squared. That's square root of 3. Yeah, it is. And then when I plug 2 in, I get 4 on the square root of 2. Okay, so let's focus on these right here, these numbers right here. My absolute minimum is going to be 2 on the square root of 6, and that occurs at x equals 0. And my absolute maximum is going to be 4 on the square root of 2, and that occurs at x equals 2. Okay? And so this is your final answer right here. Now, when you're determining the absolute max and the absolute min, it is okay if you put that into a calculator and get the decimal approximation so that you can make sure that you have the correct understanding and the correct value there when you're talking about your absolute min and your absolute max. Okay, and again, the hard part is the algebra, and the algebra just takes practice. It just takes lots and lots of practice. Okay, now the next one I'm going to do is number 45. Okay, and number 45 is asking for very similar, our absolute max and absolute min. And the interval we are talking about here is 0 to 4. 0 to 4. Okay, so the first thing that we have to do is we have to find our derivative. We have to find our derivative. And this one's not too bad to find our derivative. We've got y prime. Okay, I'm going to do this off to the side because we are going to have to use the chain rule. I've got x, so I've got the square root of x plus x squared. Okay, so for the chain rule, I'm going to have u equals x plus x squared. And then f of u is going to be u to the 1/2. Okay, and that's the square root of u, and we know that the square root of u is the square root of 1/2. So u prime is going to be 1 plus 2x. Okay, f prime of u is going to be 1/2 u to the negative 1/2. I know I'm writing off to the side there. Sorry about that. Okay, so what that means is f prime of u is going to be 1 over 2 on the square root of u in the denominator. Okay, so that means the derivative of this is going to be 2x plus 1. Okay, that's my u prime right here. And then I'm going to have in the denominator 2. And then I've got to substitute my u back in, and that's x plus x squared. Okay, so the derivative of this right here is 2x plus 1 over 2 on the square root of x plus x squared. Okay? Now to find the derivative of 2 on the square root of x, I'm going to go ahead and put my subtraction sign right there. 2 on the square root of x, to find the derivative of that, that's 2x to the 1/2. Okay? That's going to be, I kind of got ahead of myself. Okay. 2 on the square root of x is 2x to the 1/2. The derivative of that is going to be 2 times the 1/2 x to the negative 1/2. Okay, so my 2's cancel. I'm going to have 1 in the numerator. And so I'll have 1 over the square root of x. Okay, and that's the derivative of this right here. And I've already got my subtraction. So my derivative here is going to be 1 over the square root of x. Okay, now to find our critical numbers, we've got to set our derivative equal to 0 and solve. So when I set this derivative equal to 0, I get 2x plus 1 over 2 on the square root of x plus x squared minus 1 over the square root of x. And I've set that equal to 0. Now, probably, you know, when we look at this, right here, okay, so what I'm going to do right here, instead of trying to find a common denominator or anything, I'm going to take this and I'm going to just add it to the other side. That's all I'm going to do is add it to the other side. Okay, so then I'm going to end up with 1 over the square root of x. So I have added 1 over the square root of x to both sides equals 2x plus 1 over 2 on the square root of x plus x squared. Now what I've done is I've set up a proportion where I can cross multiply. So what I'm going to do now is I am going to multiply this right here together, and then I'm going to multiply this right here together. Okay, so what I end up with is 2 on the square root of x plus x squared equals the square root of x times 2x plus 1. Okay, now I've got a whole bunch of square roots in here. Now I could divide and I could try to move all the x's to the same side, but actually what would really be helpful right here is for me to square both sides. Because when I square both sides, I get rid of all of my square roots. Okay, but you have to remember, this being squared means I square this and it gets rid of the square root, but I've also got to square this right here. So when I square this, I end up with 4 times x plus x squared. Okay, so I squared this side, 2 squared is 4, and then when this is squared, I get what's inside. And the same thing's going to happen on the other side. When I square this side, square root of x squared is going to give me x, but I have to square 2x plus 1, and I do have to FOIL that in order to get that. So I do have to FOIL 2x plus 1. And when I FOIL 2x plus 1 times 2x plus 1, because that's being squared right here, I end up with 4x squared plus 4x plus 1. Okay? And now we can start solving. So we can continue solving because we've been solving the whole time. So I'm going to distribute my 4 to my binomial, and then I am going to distribute my x to my trinomial. Okay, so now what I'm looking at is I need to set this equal to 0. We've got multiple powers in here, so I'm going to have to set it equal to 0 and see if I can factor it. So let's go ahead and move this 4x squared over. So I'm moving this 4x squared over, and then I'm also moving this 4x. So I'm subtracting 4x squared and I'm subtracting 4x from both sides. So over here I end up with 0, and then I have 4x cubed. These cancel, and I'm left with minus 3x. This has something nice for us to be able to factor out. I can factor out an x. So then I'm left with 0 equals x times 4x squared minus 3. Okay, so I set each factor equal to 0, so I have 0 equals x, and then I have 0 equals 4x squared minus 3. Okay, so here's a critical number that I've got to think about is x equals 0. I think that's part of my interval though, so that's one of the endpoints of my interval. Now for this one, I'm going to add 3 to both sides. So I have 3 equals 4x squared. I divide both sides by 4, and I'm left with 3/4 equals x squared. Okay, and what I'll do then is I'll take the square root, so I'm just going to kind of go right here. I'm going to take the square root of that, so I end up with plus or minus the square root of 3/4 equals x. I can simplify that 4 in the denominator. So I have plus or minus the square root of 3/2. Okay, so I'm going to zoom out. So the interval that we are looking at is 0 to 4. And then I've got 0, so that's already covered as one of my critical numbers. And I've got plus or minus the square root of 3/2. Now, we're only going to have to deal with the plus on that. So let's move those. So we've got 0 and 4. Okay, because those are my endpoints. And then we have positive square root of 3/2 as one of my values. So we're going to have to go back to my original function and do f of 0, f of square root of 3/2, and f of 4. Now I want to go back to my denominator and just make sure I didn't miss any denominators there. And I don't think I did. So here, 0, can't take the square root of 0 here. So we've already got 0 covered. Now here, if I put that equal to 0, I think we're good there too. So that would be 2 on the square root of x plus x squared equals 0. So we would get a 1. So we're going to need to evaluate the 1 also. So here we've got the square root of x plus x squared equals 0/2. We're going to square both sides. So then I'm left with x plus x squared equals 0. And then that will be x. I'm rewriting this slightly. Oh, but that's going to be negative, so it's not going to matter. So our other critical number would be -1. And that's outside of our, when we set our denominators equal to 0 to find our critical numbers that make the derivative undefined, we would get 0, which we're already covering, and then we would get -1, which is outside of our interval. So we don't have to worry about that. So these are the only 3 that we are evaluating. And I am going to rewrite our function again, or our y that we started with. Okay, and I've got the square root of x plus x squared minus 2 on the square root of x. Okay, and so when I plug 0 into this, when I plug 0 in for all my x's, I get 0 plus 0 squared, and the square root of that is 0 minus 2 times the square root of 0. So for 0, we are just going to get 0 when I plug that back in. Now, when I plug in the square root of 3/2, for this, I get y equals the square root of 3/2 plus the square root of 3/2 squared minus 2 on the square root of 3/2. Okay, and when I put that in my calculator, I get approximately negative 0.589980. And you don't have to go to that many decimal places. I would say 3 or 4 are fine. So if we went to 3 decimal places. 1, 2, 3, that's going to bump everything up. So negative 0.59 is where we're looking at right here. Okay, so that is going to be our f of square root of 3 over 2. Okay, and then when we plug 4 in, let's see what happens when we plug 4 in. I've got y equals the square root of 4 plus 4 squared minus 2 on the square root of 4. Okay, so then we're going to end up with y equals the square root of 20 minus 4. Okay, so our decimal approximation for that is going to be y equals approximately 0.472136. And when we, let's round to the nearest, or to the 3 decimal places, so that's going to be 0.472. Okay, so y is approximately 0.472, and that looks like it's going to be our absolute maximum. Okay, so our absolute maximum is approximately 0.472, and it occurs at x equals 4. Okay, and then our absolute minimum is approximately negative 0.59, and it occurs at x equals positive square root of 3 over 2. Okay, I hope that helps, and let me know if you have any questions.